As we get closer and closer to the 9-month mark since Helene devastated Western North Carolina, there really is an invisible threat quietly emerging.
Tonight, in part one of a two-part story, Spectrum News 1 anchor Sarah Rudlang investigates the hidden health crisis growing beneath the surface.
Here we have one named Aspergillus sodowii, and this is a coral and human pathogen.
In January, a Duke University team of researchers traveled to Black Mountain in hopes to answer why people were feeling sick after Helene.
We wanted to see, after this 1,000-year flood event, what was affecting our friends and family in their homes.
Dr. Asiya Gusa helped launch the research lab called CLIFF, the climate and fungi team, to investigate, starting with hundreds of samples taken from both cleaned and untouched sites after Helene.
And this was really like a 1,000-year event that Western North Carolina had really never seen before. But we were aware that you often get these fungal blooms after flooding events, like after Hurricane Katrina, Hurricane Rita, Hurricane Harvey.
Each delicate swab, followed by careful growth in these petri dishes, is now helping the team identify fungi as friend or foe.
We're still early on, but we took a lot of samples, and we've gotten now to the point where we're able to identify, or we're growing the different species of fungi that we found and isolating them.
For Asheville native and Duke research technician Vesper Fraunfelter, the mission was deeply personal.
Seeing my home wiped out, and Chimney Rock, for instance, half the city just washed away. And I had spent much of my childhood there. And so it was terrifying.
Masked up and ready to see for ourselves, Black Mountain's project and facilities manager Angela Reese took us inside an unremediated site the researchers had sampled.
I believe this is the actual flood mark here. So you can kind of see, if you look throughout, how badly that the mold has taken over.
Hundreds of thousands of dollars in ruined equipment in this building alone, and with it being in a floodplain, demolition now deemed cheaper than remediation.
We came out to do what we could to salvage everything we could to be stewards of the taxpayers' resources and their dollars.
It was later they realized the dangers of being exposed to the growing problem.
Shortly after, you could hear people getting sick or coughing, headaches. Within hours of being in one of these facilities, you just have pounding headaches.
When Duke University's CLIFF team reached out to sample the sites, Reese says they didn't think twice.
I said, absolutely. I mean, we're all about if it furthers your research and you can use that to help recovery in the future.
Marking the first step in fighting back in the fungal fallout from the storm. Sarah Rudlang, Spectrum News 1.
Well, last night we revealed a growing issue affecting some of our Western North Carolina communities nearly 9 months after Helene. You see it right here. And tonight, Spectrum News 1 anchor Sarah Rudlang is following up by showing us how Duke University engineers are hoping to use science to manufacture a stronger defense in the future.
In the quiet, damp aftermath of Helene, an invisible threat grows in Western North Carolina.
You have enough sense to know that, oh, there's some mold, you probably need to wear a mask. So we had some masks, we had some things donated to us, and we put them on. They probably weren't what we needed.
Black Mountain's project and facilities manager Angela Reese walked us through one of the town's many sites that flooded.
You kind of know that you're exposed to things that's probably not normal. And but you really don't have the concept of what's happening.
As people began getting sick, Duke University responded by creating CLIFF, the climate and fungi team, to investigate hundreds of types of fungus found in the aftermath.
One of the things that we did when we were in Black Mountain was talk to different people about their experiences, and they did across the board talk about a dust that was over everything. And if they were exposed to that dust, they got headaches and respiratory problems and whatever else.
We just want to understand what are the risks and potential impacts on health, and how is it changing in a changing climate.
We took a trip to their lab, led by Dr. Asiya Gusa, as they isolate and identify each fungal species.
Fungi tend to be the least studied and the least resourced as far as funding, and we're hoping that that will change as folks become more aware.
As Duke's CLIFF team continues to research, The university's engineering school wants to turn those Petri dish findings into a proactive plan to help with future flooding. So the samples from the GUSA lab come here to the School of Engineering.
Yes, and so here at the School of Engineering, what we're going to try to do is figure out how these bacteria and fungi are growing on different building materials. So I'm part of what's called the NSF Engineering Research Center for Precision Microbiome Engineering. I know it's a mouthful. Shorthand is Premier, and what we do is we try to figure out how we can live with bacteria.
Inside Duke's biofilm reactor, drywall, wood, and pipe samples soak in simulated floodwater.
This is what a flood is going to look like. So let's say somewhere like 4 days or so of flood water is just sitting on that material. See how that grows and see how your changes to this material might encourage or discourage the good ones versus the bad ones.
The goal, to create future buildings that resist mold before storms even strike.
I really hope that, one, we can start answering those questions that the residents were having, right? So those concerns of what was in the air, was it making me sick? How can I help my own health out? And the second thing is really the future, right? So can we design new buildings that are going to be healthier for all of us?
I'm really excited about the collaborations that we've made with folks in the engineering department. We're going to be working with a biochemist as well to identify some of the toxins that are produced. And we might actually find novel antifungal compounds as a result of this work.
Hoping to treat today's issues and prevent tomorrow's damage. Sarah Rudlang, Spectrum News 1.
And Duke researchers are working to secure more funding to make the engineering advancements possible.
In the meantime, they hope to expand their research and visit Asheville for additional sampling in the coming months.